I'm so thrown off after last week that we were in, we went to lunch after this class. Now it's, like, in my mind that we go to lunch after this class, and we don't, and it's really annoying.
Kind of like, it's, like, adjusted, I feel like, after that one day. I'm kind of hungry.
Dude, me and Shay went to that, the new Little Caesars over there.
Is it nice?
Yeah, I like it. I mean, it's not, like, nice. It's just Little Caesars, but...
I don't even remember them building it. I just lived across the street and it was there.
I literally drove by the other day, and it was like, Little Caesars now open. I was like, where? I was like, right there?
Yeah, like...
I mean, it's kind of convenient, though, like, not gonna lie, but... I don't love Little Caesars. Like, it's fine, but I don't love it.
Crazy bread.
I like Little Caesars.
$5 pizzas, you can't go wrong.
Yeah, it's a $5 lunch combo.
Right?
And it's good. I didn't know it was new, though. I just kind of thought it was always there.
No, it just opened.
Yeah.
There was another pizza place there
Marco's?
before. No, it wasn't Marco's. It was,
Oh, I can picture it.
Papa Murphy.
That's right.
But it wasn't, like, hot pizzas. You, like, got them and took them home and cooked them.
I never
Oh, yeah,
understood
why would you
It
do
was
that?
super weird concept.
That's why we never went there, because we're like...
I think I got one time, like, we ordered, like, because I think the school did a fundraiser through them or something when I was little. I was like, I don't know.
Because, like, if we're going to order pizza, we're not...
Yeah, why would you get it? Yeah.
I mean, like, I'll go to, like, Aldi and pick up, like, a
Yeah.
pizza
That
like
feels
that,
normal,
that
though.
like,
That
is,
feels
like,
good.
already
Yeah.
made, and then, like, I'll take it home. Because I may not be doing it, like, that night, but, like, I may just want to pick it up for, like, the next day, but...
Right. But, like, a whole place dedicated to only making cold pizza? Like,
I mean, I don't know if they didn't cook any of them or if that's just not how we ever had it, but it was a very odd,
Yeah.
Yeah.
I don't know.
prefer Little Caesars.
Their whole dynamic was weird. So, anyways. All right. So, the sampling distribution model for a proportion, provided the sample values are independent and the sample size is large enough, the sampling distribution of, okay, this is technically p hat. I made a bunch of these before I figured out how to put the little hat on top of the letter. So, just know that
Oh,
these
that's
are
supposed to-
technically supposed to be on top of here. Just should be aware of that, but it's not really going to change anything other than just a notation. But anyways, but it's modeled by a normal model with the mean being equal to p, and the standard deviation is the square root of pq over n. So, for this first example, in a really large bag of M&Ms containing 500 candies, it found that about 12% of them were green. The company claims that 10% of M&Ms produced are green. Is an unusually large proportion of green M&Ms. So, I actually did this as a science experiment in, like, AP Biology one time. Like, we did this to, like, test, like, what company... I don't remember exactly what we were testing anyways. All I remember was opening a bag of M&Ms, and we counted, like, each color, and we saw if the proportion matched, like... Apparently, you can just Google what proportion the company says you're supposed to get of each color, and they are not proportional. You would think, like, oh, there's 5 colors, it'd be 20. Like, it's not. It's super random. Like, blue, I think, was, like, the least common color at the time or whatever. Anyways, and we had to, like, write a whole paper about it. It was a good time. Like a science write-up about, like, I think it was just testing, like, a hypothesis testing or whatever. Like, scientific method. Like, I think it was...
Yeah.
I don't think it had any, like, actual science significance other than just for that. But anyways, so I have done this before. I don't know. If I make it to get some M&Ms at some point, maybe we'll do this and see what happens. Just and, like, get, like, the little fun size. Not the fun size, but, like, the normal size packs. We'll see. If I remember sometime when I'm at the store to pick them up, maybe we'll do it. But anyways, so they tell us that we should have 10%, but in the bag that we have, quote unquote, we found that 12% were green. So the mean, according to them, should be 0.1. The standard deviation is the square root of P, which is 0.1, times Q, which is 0.9. So remember, that's just the success failure. So 1 minus whatever P is Q. Over N, which is 500. Because there were 500 M&Ms in the bag or whatever it is. And when we do that... that's the wrong button. I get 0.013. So I'm going to set up a normal model. So, and I'm going to make it kind of obnoxiously large because I'm going to have decimal places in here. Oh, that was not good. Close enough. All right, so the mean here is 0.1. And then over here, this would be 0.113. Here would be 0.126. Right? Yeah. And then this would be 0.139. Yeah. And then going backwards, oh goodness, I'm gonna have to think about this one more. I'm just gonna
87.
I'm just gonna do this one by hand.
Wait, never mind.
0.1 minus
0.087.
0.013.
There we go.
Okay, yeah. 0.087 minus 0.013. I used to be so good at doing stuff like this, and like now I'm not.
6-1. I'm calling it.
Yep.
Zeros.
Oh yeah, my bad.
All right. So when we have a normal model, where do we classify as unusual?
Past 2.
Yep. Anything past 2. So that means that I need to be in this range here. So this is 12.6%. So if I was past 12.6%, I would think it is unusual. But 12% is not, because that's inside the 2 standard deviations. So no, not unusually large. %12 is less than 2 standard deviation from the company's I'm going to say like mean. So not unusual. Guess that's a little bit redundant, but that's okay. Grief, you got a whole bag of markers?
Well,
What?
I had some that I got from my box at home because I was going to do this. I was like, why not use it for this too?
Nice.
Yeah. I have a giant box just of random markers that are from, like half of them are probably from like 7th grade. But you know.
No, that's fair. I was just like, what in the world?
I use them for my Bible journaling.
Nice.
I gotta be more like diverse with my highlighting because I use just one color highlighter for my Bible, and I feel like it's not aesthetic at all, you know, because like. I'll see
Sometimes
the-
I want everything to look the same, and then sometimes I want like certain stuff to like stand out.
Yeah.
I decided in my like journaling Bibles I want like colors. Like it's make it as colorful as possible.
Nice.
Do the colors mean anything, or is it just colors?
No, like so I'm highlighting because I'm going through it all again. So I'm like highlighting every verse that I read, like so I can see what all I.
Every verse you read?
Yeah, like it's the whole thing's gonna be highlighted, and like things that stick out to me I'm underlining. But I have like a few. That's just like my journaling one though.
Still, that's a whole Bible
Yeah.
highlighted.
Yep. But they're
That's a
pretty
lot.
colors.
That's cool.
I switch it up every chapter because I have to read like 4 a day.
Are you doing like in the end of your thing?
But I like divide it up differently. So like I read. So if I have to read 4 chapters of Joshua one day, I read 3 the night before and then 1 when I wake up. So that I'm like done for the day.
Nice. That's cool.
Yeah.
Yeah, my friend, so in our Bible study, we were doing a thing about, like, it was a book about, like, the different, like, attributes of God. It was called In His Image, and so it was, like, talking about how, like, the attributes that He has, like, how we, like, for example, like, being holy, like, obviously we can't, like, we're called to be holy, but we can't be perfectly holy, like, apart from, like, him, like, obviously, and stuff. And so we were talking about, like, how many verses in the Bible actually, like, have the word holy in them. And I can't remember. It's some, like, insane number of, like, how many times the word holy is used. But, like, we didn't start this till, like, last summer, because I was doing, like, the Bible in year. They're like, you should highlight every time you see the word holy and stuff like that. So I'm like, at some point I want to, like, go back through and do stuff like that, or, like, every time you see the word, like, love or holy or whatever, and, like, have, like, a color designated for that. But I decided to do something different this year, so I'm not going to do it. But maybe next year I'll go through and, like, do that.
With, like, sevens, because I know 7, like,
Mm-hmm.
Yeah, it's a lot.
yeah, but it was a lot. I was like,
It's like 7, it's 40, it's 3.
Yeah.
3's a lot.
Yeah.
What's the other one?
I
I think there's another one.
feel like there's 2, but
12. That's what it is.
Oh, yeah.
So, yeah. Yeah, there's a lot of, like, random, like, number significance
Yeah.
things. That's kind of cool, though. So, but, yeah. I don't know. But, yes, I get what you mean. I have a lot of colors for stuff like that, too, so.
it makes it more fun.
All right. Next problem. Public health statistics indicate that 26.4% of American adults smoke cigarettes. Use the 68, 95, 99.7 rule to draw and label the distribution of the proportion of smokers among a randomly selected group of 50 adults. So, first of all, I'm going to write out the mean is 0.264. Standard deviation is the square root of 0.264 times, 0.736. Yeah. Over 50. And that is equal to 0.062. So that's our standard deviation there. So to draw my little normal model, I've got my mean 0.264. Oh dear. My calculator wasn't even on. I hate that. All right, 0.326, 0.388,
Wait, what number are you going up by?
0.062.
Oh, okay.
And then this is 0.45. If you want to keep it consistent, you could put a 0, but like is literally just 0.45. And then going down, 0.202, 0.14, 0.078. And then since they specifically want us to label the 68, 95, 99.7, I need to go in and add that in. So one standard deviation away is the 68%. 2 standard deviations away is the 95. And then 3 is 99.7. All right, so now, do you think the appropriate conditions necessary for your analysis are met? So we're going to look at the conditions for this, which technically we would want to, probably should have done these in opposite, but technically you'd want to check the conditions before you go through and do everything else. But anyways, so our conditions... Is it random? Yeah. So I usually just do little stuff like this. So random, little check mark. 10% are 50 adults less than 10% of all American adults. Yep. And I would usually just, again, you don't need to necessarily do this when you're doing the problems, but just for, if you go back and look, 50 adults is less than 10% of all American adults. And then success failure. So I usually just write SF for success failure, shortens it, and I know what that means. So NP needs to be greater than or equal to 10, and NQ needs to be greater than or equal to 10. So that's 0.264 times 50. Is 13.2. And then obviously the other one's going to work out 0.736 times 50. It would be what's left over. So what is that? 36.8. So obviously that condition is also met. Both of those things are greater than 10. And so then to like conclude all of that, we would want to say the conditions are met. So a normal model is appropriate. So obviously, like I've said many times, but typically all the conditions are met unless it's a question that's just asking you that. Then they may be trying to trick you or trying to get you to like make sure you pay attention to that. But typically if they go through all the effort to give you this full-blown problem, the conditions are going to be met. But overall, we would want to check conditions first because there's no point in doing anything else if the conditions aren't met.
Is it okay if I sit in here next period?
Just don't forget to tell Taylor.
I won't. Do that first thing. I'll visit her, then Mr. Flowers, and I'll be back.
Did y'all get all of this one?
Yeah, I'm just writing myself a little note.
Okay. You just don't want to take it away too quick.
Yeah.
Let's do it.
I was earlier, yeah. Got 2 names so far.
All right.
Cherry limeade right now. Smells so good. Because my color scheme reminded me of cherry limeade. Because it was like pinkish red and green.
I don't like anything like that. I don't like cherry and I really don't like lime that much.
I love it.
I grew up on cherry cough syrup though, like,
Oh, yeah,
and
that's
so like pretty much cherry just in general. Well, see, I say that, but then like I put that like the cherry syrup stuff in like my ginger ale
Oh,
with
yeah,
the coconut, like the pina colada mix, like
Maybe that's why I don't
stuff.
like grape.
So yeah, Dimetapp.
I don't know what brand, but
Oh
grape
yes.
cough syrup.
Well yeah, it was like cold and allergy medicine, but
Yeah.
yes,
Used to have
Dimetapp is the name brand. So we never had the name brand. We just had Walltap.
Yeah, there was one that I liked. Like there was a like grape one that I actually thought was pretty good. But then there was this other one that just like.
There's one brand that makes that. Like I think it's like I was gonna say like Eckerd's or something, but I think it was Rite Aid. But anyways, but theirs is very like. How do I put it? Like alcohol-y tasting, like not like
Yeah.
rubbing alcohol.
Yeah.
Like it has just like a very strong like flavor to it, and I just like getting that down. I was like, I don't normally like now at this point I'm not really bothered by it because like I'll still take it sometimes because honestly it's kind of more effective than a lot of other things that
Yeah.
you can take.
Yeah.
And I like had that. I had stopped one day because I just could not stop sneezing, and that was the only like place on my way home that I could stop. So I like went in there and I was like, whoa, like that stuff was strong.
I cannot do liquid medicine other than like the pink one they give you when you have an ear infection.
Pink was not awful, yeah.
That one's
Amoxicillin.
good. Yes, I love. But other than that,
Oh wait,
Tamiflu
amoxicillin.
ruined everything for me.
Yep, Tamiflu ruined like all orange
It
flavored
tastes
things.
Like burnt, like rotten oranges.
Yep,
It's
it kind of
disgusting.
tasted like orange dish soap.
Ugh.
You know what orange dish soap tastes like?
No, but like if I had to like put a
Smell
flavor
it.
to an orange dish soap, that's what
what it is.
that's what it would be.
It made me
And it
more
was
sick than
chalky.
the flu.
Yes. Yes. I agree. I got super sick after.
Yes.
It's nasty.
I couldn't keep it down either. I was like, Mom, no.
They make pills for it now. Apparently, I don't know if they have it around here, but last year when my cousin had the flu, they gave her a shot and she was better in 24 hours.
That's nice.
I would 100% take that over.
Right?
Cause, and then they said they would like flavor the Tamiflu for me, so they put strawberry in it.
Didn't help.
No. If anything, it makes it worse.
Yeah. Well, the good news is knock on wood. But not many people have the stomach bug anymore around the school, so we might be past that at this point. There are a couple little kids that still have it, like down in preschool, but
Yeah.
fingers crossed we are
No.
past that point.
Please. Because I was a little scared coming to school Friday. I was like,
Yeah, me too. After I got to like the nighttime on Saturday, I was like, I think I'm good.
I think we're in the clear.
All right, next problem. Assume that 30% of students at a university wear contact lenses. We randomly pick 100 students. What are the mean and standard deviation of the proportion of students in this group who may wear contacts? So the mean is 0.3. Standard deviation is the square root of 0.3 times 0.7 divided by, what is the number, 100?
Oh wait, that makes sense. It clicks. It clicks now.
That's good.
I don't know how long that'll last. I might forget in like a day or two, but it clicks right now.
So 0.046. All right, before we do part 2 of this question, because we would need to know about the conditions. Oh, look, in this one, the little hats are on top of them already.
You like figured it out that day?
Whoa.
I suspect I went back and edited the document and forgot to edit the first page. That's what I suspect happened, but I could be wrong. Who knows? Sometimes I figured it out, and then sometimes I would like copy and paste them, and then it didn't work, so then I
Yeah.
just gave up. I was like, I'll just tell them.
Yeah.
All right, so I'm going to jump down to C so that we can look at the conditions first before we do anything else, because we should do that, and I don't want to just say, assume the conditions are met, and then go find them in a minute. So, all right, so what assumptions underlie your model? Are the conditions met? So as far as random, is it random?
No.
We randomly pick 100
Oh.
students.
Yeah, never mind.
So yes, they're randomly picked. All right, 10% condition. Are 100 students less than 10% of all university students?
Yeah.
Yes. So 100 students less than 10% all university students. And it's even a safe assumption to say, even if we were just looking at that particular university, that 100 would be less than 10%. There are very, very few universities that have less than 1,000 people. So I think it would be a safe assumption either way, but we're looking at all of them. All right, so success failure. So N times P is 0.3 times 100. N times Q is 0.7 times 100. So we've got 30 and 70. Both of these things are greater than or equal to 10. So that condition is met. And then is that sample too big or too small?
No.
Correct. Sample size large enough, like, but not too large.
When is it too small again? Isn't it like less than 10?
Less than 10.
Okay.
Or like the success failure is greater than or equal to 10. So you just kind of have to gauge, like, basically you have to have, I think, I can't remember what like the minimum number you would have to have for it to even possibly like start to like work, but I think it's like 20, around 20. But it also depends on what your success failure rate is a little bit to do that, because obviously 30 and 70 add up to 100, so like that's your total. But and then as far as 10%, it's got to be less than 10% of all. That's when it becomes too big, is if it's more than 10%.
Okay.
But again, we very rarely have that problem in what we're doing. Now, if you were actually doing analysis in the real world, yes, that could
Maybe,
start to
yeah.
become a problem. All right, so back up. Let P hat represent the proportion of students in this sample who wear contacts. What's an appropriate model for the distribution of P hat? So based on the fact that these conditions are met, what type of model do you think we should use? Yep. So normal model. Keep looking for pockets on this to stick my hands in, and there's not pockets on this jacket. All right, and so the normal model is the mean. We set it up like this in the standard deviation for like how it sets up. And obviously, again, part B is under the assumption that our conditions had been met, so that's why we went ahead and did that part first.
So for that, like, we don't have to draw the thing, we just have to write like that.
Right.
Okay.
Nothing wrong with drawing it, but we don't really need it for this particular problem. All right, what's the probability that more than 1/3 of this sample wear contacts? So we would find our z-score first. So z equals what we're trying to find, so basically 0.33 minus, so predicted minus actual, actual minus predicted. I was like, that's wrong. So actual is 0.33 minus the predicted is 0.3 because it said that we had 30% that did. And then, or that's their assumption, over the standard deviation, 0.046. And that gives us 0.652. And then now we will use normal CDF. Of 0.652, 1 E99, or 1 times 10 to the 99th, and then 0 and 1. So since it's normal, we can use 0 and 1. So that's under second VARS, which is distribution, and then it's one of the first two options. So 0.652, 1E99, 0, 1.
So 1 times 10 to the 9, that's
The 1E99,
Okay.
yeah. So on your calculator, it would be 1E99 like that. And then this comes out to be 0.257. And so then we would want to wrap this up to conclude what we're saying here. And so according to the normal model, the probability that more than 1/3 of students in this sample wear contacts is about 25.7%. And remember with the random, the other option we can also have is that it's a representative sample if it doesn't specifically specify that it's random. Just random thought that I had.
Say it one more time. I'll make sure this doesn't even know.
So, like the random condition, if they don't specify that it's random, but we can tell that it's like a representative sample, that also works. So, like some of the conditions will say random or representative sample. But in ours so far, we've basically known that it was. So it wasn't a problem.
What's like an example of one that would be like if they didn't tell us it was, or would they tell us it
It won't, but you'll kind of just know, like, if it's, like, all of the people that went to Olive Garden on Sunday for lunch kind of thing. Like, you'd kind of be able to tell. Like, yeah.
You have to like specify or tell why you think it's random or just.
No, I mean, it's one of those where, like, because random is more, like, we just randomly grab people and start asking them questions.
Okay.
But representative would be, like, we don't have control over, like, who came into the restaurant, so, like, obviously that part's random, but then, like, if we, like, ask everybody that's in there, we would just say it's representative of, like, the city of Newport News for everybody that ate lunch at Olive Garden on Sunday, kind of thing. I'm going to skip number 4 for right now because of the sake of time. I'm going to jump to number 5 because I think we can actually finish 5, and then we'll do 4 and 6 tomorrow, and then we'll be done. So, jumping to the last page.
Groovy M&Ms.
Actually, let's save 5. Let's do the M&M one.
Which one is 6?
The groovy M&Ms. I think at some point they were actually like a special item. I suspect it was kind of like when I think of like groovy, I kind of think like throwing back to like the what is it, like the 80s. Yeah. So I suspect it was some throwback to something from the 80s and they were special, but everybody always asks me what groovy M&Ms are. I'm like, I don't know. I think one year I googled it and it was like something, but I don't know.
I was thinking they were like cheese and groove. Like
Oh.
M&Ms shaped like a cheese.
Yeah, one time somebody
that's
asked
kinda
me if
good.
they had M&Ms that had like ridges, and I was
Yeah.
like,
That's
no.
What that's what like, I pictured. It's like,
That sounds
oh.
kind of good.
I know.
I'm like, I have no idea, but anyways.
Especially
Just
if they're,
is what it is,
fruit
I guess.
size, like, that big, it's an
Yeah.
M&M.
I kind of want that now.
All right.
I don't even make that.
Yeah.
So in our special promotional bag of groovy M&Ms, they're supposed to make up 305 of the candies in the bag. There also could be like something mixed in with the M&Ms. I have no idea. In a large bag of 250 M&Ms, what is the probability that we get at least 25% groovy candies?
I don't know.
So, oh wait, this is supposed to say 30%, I think. Is the percent sign on the 5? Yes, it is. The percent sign is on the 5. So, apparently that didn't, I was like, something here is missing. It's like some piece of information that I need is not right. Okay. So, let's look at conditions first. Is this random?
Yes.
Yeah. Each bag would be random. 10% condition is 250 M&Ms less than 10% of all M&Ms.
I hope so.
Yes. Success failure. So N times P would be 0.3 times 250. Which is 75. And then NQ would be what's left over. So that 175. And both of those are greater than or equal to 10. So that condition is met there. So what should I use?
And then normal model.
Yep. You can tell a trend here. So a normal model is appropriate. And that's going to be for the mean of 0.3 and the standard deviation of, I guess we didn't find that yet. Let's find that. Square root of 0.3 times 0.7 over 250. Which is 0.029. All right, so we're going to find our z-score So Z equals actual, which is 0.25, because they want us to do at least 25%. So that would mean that the Y bar is 25%. Or I guess I should actually write this as 0.25. It should be written as a decimal. Minus predicted is 0.3 over 0.029. And that gives me negative 1.724. So then I'm going to do normal CDF. Negative 1.724, 1E99, 0 and 1. And when I do that, I get 0.95 rounded 8. So according to the normal model, also notice a trend in how these are wrapped up. According to the normal model, the probability the bag has at least 25% groovy M&Ms is about 95.8%. So I would think probably 20 minutes or so tomorrow, and we'll finish this, and y'all have time to work on stuff. And then my tentative plan is Wednesday that we will do the notes for the next chapter, and then y'all will have some more time to work on this stuff if you don't get it finished tomorrow. But that's where I'm at the moment. So, anyways.
So the point or the Z-score goes first because we're saying it has to be at least that?
Yeah.
Okay.
So like we, like if we were to look at the little like model of it here, we want bigger than 0.25, so it would be this area over here.
Okay.
If we were wanting less than 25%, then we would do like the negative 1E99 to whatever that number is that we're looking at. So, yeah. And then that would give us or we could just in this case do 1 minus this number, and that'll give it to us also.